Welcome to the series of lecture on solar energy fundamental. In previous lecture, we had discussed the angle of declination, latitude and longitude based on the earth-centric coordinate system. On the same line, now we'll try to understand another angle called the R angle. The earth-centric coordinate system with the three axes, polar axis, meridional axis and equatorial axis are shown in figure. The line OA represents the insolation, that is the rays which are coming from the sun, and OA dash is its projection on the equatorial plane. The angle which is subtended between the meridional axis and projection of line of insolation on the equatorial plane is an angle omega, and this angle is known as R angle. This angle used to define the angular displacement of the sun from east to west. The audience may please do not confuse with the statement, the sun never displaces from its position. It is the earth which revolves around the sun, and due to this motion of the earth, the sun appears to be displaced from east to west. The sun takes 4 minutes for displacing its position to each degree of longitude. So this displacement of sun is termed as the apparent motion of the sun. To understand it, let us consider the wired globe having the longitudinal line starts from the north pole and end at the south pole are drawn at an interval of 15 degree around it. Now let us assume that if we see it from the top, then it will look like a circle. The center of the circle represents the north pole, and the circumference of this circle will represent an equator. The line emerging from the center of the circle and touching the circumference of the circles are longitudinal lines. Now assume that the line emerging from the center of the circle and extended to its south is a prime meridian, which is also known as Greenwich Mean Time, where world time is determined. The line extended opposite to it in north direction is an international date line. When anybody crosses it, the date will change. The date line generally run north to south from pole to pole through Pacific Ocean, and it zigzags around political borders of the nation, hence does not cross nations. For example, it follows the zigzag pattern while passing across the eastern Russia and Alaska islands. It do not pass through the nation because of obvious reason of avoiding two different dates in any nation. To determine the R angle, first we need to mark the reference longitude where observer is standing and wants to measure the R angle. Here we assume that the prime meridian is 0 degree longitude line is our longitude of reference. Further, we know that the sun always rises to the east and set to the west. Now let us assume that the sun rises in east and at vertical to 90 degree east longitude. It means if an observer is standing at a place on earth where 90 degree E longitude passes, then the sun rays falling on his face perpendicularly. But here for the audience I would like to clarify that it is not necessary that sun always rises at 90 degree to the longitude of reference. Here, just for the sake of the initial understanding, it has been assumed that the day length is of 12 hours and hence sun takes 6 hours to reach to longitude of reference from the longitude of rise, and next 6 hours to travel away from the longitude of reference to longitude where it finally sets. The angle subtended between the longitude which faces the sun directly, that is 90 degree east, and the longitude of reference, here we have taken it as a 0 degree longitude, that is prime meridian, is called R angle, which is represented by a Greek letter omega. Here the magnitude of an R angle is 90 degree. Further, we already know the earth takes 24 hours to rotate about its axis. It means for 360 degree rotation, earth takes 4 minutes for each degree of rotation and 1 hour duration for displacing 15 degree. Earth continue to revolve around the sun, and then the sun will appear to change its position with respect to the observer standing at the longitude of reference. For example, for every 15 degree of earth rotation, the sun appears to approaching the prime meridian with same degree of displacement. For example, here we are taking the earth start revolving around the sun west to it, so that the sun appears to move from east to west. In next 1 hour, the earth rotates by 15 degree and sun apparent position changes from a longitude of 90 degree to 75 degree east. Here sun appears to vertical to the longitude of 75 degree east. Hence the angular displacement of longitude where sun appears to be vertical and the longitude of reference is 75 degree, and this angle is called an R angle. Similarly, for the sun's apparent position at 60 degree east constitute R angle 60 degree. At 45 degree it constitutes the 45 degree because the difference in angle between the sun rays directly falling on the longitude and the longitude of reference. Similarly, the earth continue to rotate, and for 30 degree the R angle is 30 degree, and for 15 degree it is 15 degree. Since earth relentlessly revolves around the sun, hence due to this motion of the earth, the situation arises when the longitude of reference is directly facing the sun. In such a situation, the R angle will be 0 degree because it is the condition where longitude of reference and the longitude which faces the sun directly are same. This situation is called as solar noon for the place where longitude of reference passes. Means the people who are at the observer who is at the prime meridian, for him this is the situation for the solar noon. Similarly, the sun position appears beyond the longitude of reference. Earth continue to rotate, then a time will come after solar noon when sun position appears to the west of the longitude of the reference. I mean, now the meridian located in the western hemisphere faces the sun. With every 15 degree of the earth rotation, sun seems to be positioned at 15 degree west, 30 degree west, 45 degree west, 60 degree west, 75 degree west, and finally at 90 degree west. This is the position when sun sets. Based on ongoing discussion, we can define R angle at any instant of time as an R angle is that angle through which earth must be rotated to bring the meridian of location or longitude on earth's surface directly under the sun with respect to the longitude of reference. When the R angle is 0, then such condition can be termed as solar noon. We have already learned about the R angle. R angle is the angular distance between two meridian plane, out of which one carry the longitude of reference and other one carry the longitude which directly faces the sun at that moment of time. R angle is represented by Greek letter omega. For the northern hemisphere, by sign convention, it is taken as negative when sun is positioned in the eastern hemisphere, and it is considered to be positive in afternoon when sun is positioned in the western hemisphere. For southern hemisphere, the sign conventions are reversed to those followed for northern hemisphere. Mathematically, it can be expressed as omega equal to 15 into St minus 12, or another equation by which the R angle can be represented is 15 into LAT minus 12, where St is the solar time of the reference meridian and LAT is the local apparent time of the reference meridian. However, both the term solar time and local apparent times have one and same meaning, just names are different. But solar time or local apparent time doesn't mean your clock time at standard meridian. The clock time at standard meridian is based on mean solar time. We can understand these equations of an R angle by assuming the value of solar time is 12, and by placing the value in the equation, 12 minus 12 comes out to be 0, and hence value of the omega will be 0, which indicates that when R angle is 0, we call it the solar noon. The standard time of places mostly differs from one place to another because each degree of longitude has difference of 4 minutes. Standard time is the time of clock at the place is also known as the mean solar time. Standard time of any place may be different than the solar time or local apparent time of the place. To understand it, let us take the case of India. The mainland of India is extended between the longitude of 68 degrees 7 minutes east and 97 degree 25 minutes east. The easternmost longitude touches the state of Arunachal Pradesh in the east of the country, and 68 degrees 7 minutes east longitude touches the state of Gujarat is the westernmost side of the country. There is a difference of about 2 hours between these two places located at two extreme points of the country. Hence, it is necessary to adopt the local time by mentioning some central meridian of a country as the standard time for the country for administrative region. In case of India, longitude 82.5 degree east, or we can say 82 degree 30 minutes east, is considered as the standard meridian for India. The local time stated or mentioned at this meridian is considered as the standard time for the whole country. That is why the clock timing for whole of the countries are same, and they are termed as Indian standard times, which are measured from the meridian of 82 degree 30 minutes east, passing through the central part of the country. Solar time or local apparent time can be calculated by using the following equation. LAT is equal to standard time plus minus considering the longitude of standard time and longitude of location. Longitude of standard time, as we have seen recently, for the India it is 82 degree 30 minutes east. Similarly, for other nations, they have their own longitude of standard times. And longitude of location is the observer, the place of the observer is the longitude of location, plus equation of time. This E is the equation of time for time correction is used, and it can be calculated by using the equation. And in this equation, the angle A is based on the day of the year, and it can be calculated by using this equation, 360 within bracket n minus 81 divided by 365, where n is nothing but it is the Julian day of the year. It indicates that at a different day of the year, the value of E is different, and that is why the value of the local apparent time changes for any of the location throughout the year. This concept of the equation of time is introduced due to factors associated with the Earth's orbit around the Sun. The Earth's orbital velocity varies throughout the year, so the local apparent time or solar time varies slightly from the mean solar time, or we can say the clock time. The difference between the local apparent time and mean solar time is called the equation of time correction, and the concept of this equation of time arises because of one is the length of the day. Length of a day is the time required by the Earth to complete one revolution about its own axis with respect to the Sun, and it is not uniform throughout the year. Over the year, the average length of the day is 24 hours. However, the length of day varies due to the eccentricity of the Earth's orbit and of course its tilt from the normal plane of its orbit. Another reason is its elliptical path. The Earth revolving around the Sun in an orbit which is elliptical in shape. The Earth is closer to the Sun on 3rd January, this position is called the perihelion, and furthest from the Sun on 4th July, this position is called aphelion. Therefore, the Earth's orbiting speed is faster than its average speed for half of the year, that is about October to March, and slower than its average speed for the remaining half of the year, which is about April to September. To accommodate all these variations of the Earth's speed and its tilt, the concept of equation of time is introduced. Equation of time is based on the particular day of the year, which accommodates the Earth position from the Sun in its elliptical path as well as speed.